All right, number 6, the last one of 2008. I think it calls for celebration. Woohoo! That's my celebration. So, equation for the line tangent. You guys are all so awesome. You should see equation of the line, and automatically the first thing you should think is point slope form. Bam. So all we need to know is a point the line goes through and the slope of the line at that point. Well, they are really, really nice to us because they give us the x-coordinate of the point that the line goes through. So we just have to find the y-coordinate. And the only thing that's going to give us a y-coordinate is the actual function itself. So we need, okay, there we go again. It is tripping out. We need the function evaluated at e squared. So I'm going to plug that in to this equation. Ln of e squared and e squared. Now, two ways to look at the top. I can bring the 2 in front of the ln, and everyone knows ln of e. Well, we should know. It's just 1. Or another way to look at it, these are inverse functions. The ln and e cancel each other out. So we get 2 over e squared. That's the y-coordinate. So now, very wonderfully, I can plug this in for the y-coordinate. Plug e squared in for the x-coordinate. And I'm almost there. Almost done. If I only had the slope of the tangent line, I wonder what tells me the slope of the tangent line. Golly gee, I don't remember. Oh, isn't it the derivative? Isn't that the first thing we learned about the derivative? It's the slope of the tangent line. So if I find the derivative at that point, that should give me the slope of the tangent line. Well, like we said before, those are going to cancel because they're inverse functions we're dealing with. So it's going to be negative 1 over e to the 4th. I'm going to take that beautiful answer and plug it in for the slope, because the derivative does tell us the slope of the tangent line. And I am a happy man, because there is the equation of the tangent. Do I need to rewrite it to change it in any way? No. It doesn't say what specific form they want, so point slope form is fine. So we could do slope intercept, but we do not want to make a mistake. If we were to rewrite it incorrectly, we'd lose our point that we have received. So let's stop there. Let me erase this. Hopefully we won't need any of this stuff. All right. Find the x-coordinates of the critical points of f, and we will determine if it's a relative maximum, relative minimum, or neither. So what are critical points? You should all know that's where the derivative is 0 or undefined. So we have the derivative here. When is a fraction equal to 0? A fraction's equal to 0 when the numerator is 0. And when is a function undefined? When you have a fraction, it's when the denominator is 0. the bottom, the first equation, 1 equals ln of x. Ln of what equals 1? You could just know it's e, or to get rid of the ln, you can e raised to the power of each side, so e equals x. And we don't consider x equals 0 because it's not part of the domain, because we were told only for x greater than 0, the function ln of x does not exist at 0 or to the left of 0. And just a reminder, let me do a quick rough graph of ln of x. That's ln of x, just for reference for the rest of this problem. So we have to determine if this is a relative max or min. The justification, we can see if the derivative changes signs. There's also the possibility of second derivative test, but I don't want to do that right now. If we have to, we will. But I don't think we have to. Ooh, that's a beautiful box. That is beautiful. So we're going to take a look at x and the derivative of f. A number left of e is like 2.7. What would be a nice number to plug in? I like 1. And bigger than e, I like e squared. You'll see why. So if we plug in 1 into our derivative, we're going to get f prime at 1. Now, you could do this in your head, but I will just show you what's going on. Well, ln of 1, if you look at our graph, is 0. So clearly this is positive. Now, again, you could have done that in your head, because if you knew ln of 1 is 0, you look in our derivative, that's given 1 minus 0 is clearly positive. The denominator is clearly positive. It's going to be positive. And then e squared, why did I pick e squared? Because ln of e squared is just 2. So if you look at the derivative function, you have 1 minus ln of e squared over e squared squared. But 1 minus ln of e squared is 1 minus 2. Clearly that's negative. But again, you could have done that in your head, knowing that ln of e squared is 2, and you see 1 minus 2, so that quickly it's negative. Now at e, we realize the derivative changes from positive to negative, so our conclusion, there is a relative maximum at x equal e, and the reason, because f prime of x changes from positive to negative at x equal e. All right, we're done with 2, A and B. Now we're going to go on to C and D. I'm hoping this goes relatively quickly because these are taken forever, and I know you don't want to spend forever listening to my wonderful voice. And for those of you with OCD, I think I can get rid of all the dots. Bam, look at that, it's beautiful. All right, part C. We're looking for inflection points. When you hear the word inflection point, you should automatically think the second derivative changes signs, and they want the x-coordinate of these points. So we need to find the second derivative. We have the first derivative. It is a fraction, so we have to use a quotient rule. So we copy the low, take the derivative of the top. The derivative of 1 is 0. The derivative of ln of x is 1 over x, so it's low d high minus high. We copy the top. D low, derivative of the bottom is 2x, all over the bottom squared. So if we simplify the first part, we get minus x minus let's go ahead. Do I want to distribute this? Let me think. I think I'm going to need to. So I'm going to actually, we're distributing the minus sign and the 2x. So minus 2x, and then plus, because we have two negatives, 2x ln of x all over x to the fourth. So we again need to find where this is 0 or undefined. The undefined is going to be 0, which is not part of our domain, so we're not even going to look at that. So at this point, we're going to set the numerator equal to 0. We can factor out an x. Set each of those equal to 0. Add 3 to both sides on the second one. Whoa. Divide both sides by 2. And e both sides. Now again, this one we can ignore because our domain is greater than 0. So that's not even part of our domain. Now we have to make sure that the derivative changes signs at this point. So we are again going to make a beautiful table. That is so nice. Perfectly straight lines. I love it. And we're going to plug into our second derivative, which we have above us. Again, we're doing ln's of things, so let's get really nice numbers. How about e to the first and e squared? That's left and right of e to the 3/2. I think that's going to be nice. So if we plug in e, we're going to get minus e minus 2e. That's minus 3e plus 2e. And ln of e is e over e to the 4th. You know, I probably should have been smarter than this. Okay, so e squared, 2.7 something squared. Let's say it's 2.5 squared, which is, that's 6.25 times 2 is 12 point something. Clearly that's bigger than minus 3e, so it's positive. Now I think we could have made life easier if we looked at our simplified form. So if we would have looked at just this, yes, that would have been much more beautiful. So if we would have plugged e in there, am I a liar, liar, pants on fire? I might be. I'm going to start this whole thing over because I'm a liar, liar, pants on fire because I don't know how to do my math. What did I do here? So, oh, I know what I did wrong. Me, not very smart. So ln of e is 1. This is 1, not e, lame-o. So that would be negative. Clearly, this is 2e. Clearly, it's negative. I hate when things don't work out, like I say. That's negative. And if, again, like if we looked at this highlighted portion I showed you here, ln of e is 1. Negative 3 plus 2 is clearly negative, so that would have been faster. And then if we do the e squared, this one, negative, if we plug it in here, ln of e squared is 2, so that's going to be negative 3 plus 4. That's clearly positive. The bottom's clearly positive. So bam, we do have a sign. Whoa, I don't know what just happened. Let's get rid of that. We clearly have a sign change there. So we can say there is an inflection point at x equal e to the 3 halves, and the reason because f double prime of x changes signs at that point. All right, we're almost done. One more to go. And this last one is pretty nice. So let me erase. Oh, whoa, that was weird. Uh-oh. Things aren't wanting to leave. There we go. There we go. You're welcome, all you OCD kiddos of mine. All right, part D. We want the limit as x goes to 0 from the right. The limit as x approaches 0 from the right of ln of x over x. Now, if you look at the graph, as we approach 0 from the right, the graph goes down towards negative infinity. So the top would be negative infinity, and the bottom, you're approaching 0 with positive numbers. So now if the top was just a constant, negative constant, you would get negative infinity. But even more so, since it's negative infinity, and you're dividing by 0, clearly you would say negative infinity. We are done. That's one FRQ. Hopefully you survived. These are turning out rather long. But I'm going to start working on 2009. That's next. I'm getting tired because I'm also doing the BC ones. But I will make it. And so will you guys. All right? Talk to you soon again. Bye.